Let's discuss a problem from strength of materials. So what is asked is dimensions of the beam are given, the cross section details are given, the loading intensity is given, and the maximum tensile stress is asked. Now in a beam, when a load something like this acts, okay, so there is always a bending that is created, and because of the bending on one side you have a tensile and the other side you have the compression. So now we use the 200-year-old bending equation m by I is equal to sigma by y, and we represent y here. Now I is basically the area moment of inertia which is not changing, okay, and y is basically uh, the distance of the external fiber from the neutral axis, so that is also not changing. So throughout the cross section, because it's a uniform cross section beam throughout, the only thing that is changing is the bending moment, and the bending moment, remember that, so wherever it is maximum, the bending moment depends on the load, and now wherever the bending moment is maximum, there you will be getting at the maximum tensile stress. Now in this cantilever beam, when you have a loading like this, and if you go from right towards left, the maximum bending moment will be occurring at the fixed end. Okay, so let's first find out the bending moment. Okay, bending moment because of this loading. So for that I can represent this WL by a single load, which is W into L by W into length over which W is acting, so WL by 2, and it is acting at the middle, so it is L by 4, and this distance will be 3L by 4. So the moment that is produced by this distributed loading is this concentrated load into the distance from the fixed end, so it is basically 3W L square by 8. So that is the moment that is produced at this fixed end. So now everything I know, I'll just substitute this in this formula. 3W, W is 10 power 3, again kilonewton, so kilonewton per meter. Okay, so let me just everything in Newton and mm. Okay, L square, L is 1 meter. Okay, so or I mean, in order to make everything simple, let's substitute everything in Newton. The load should be Newton, so forces in Newton and lengths are in meters, so we'll keep in that way. So sigma, okay, or first substitute, let's substitute m as 3WL square by 8, so this is m. Okay, I value is given, y is depth by 2, and this is the value of I. So everything, let's substitute. So 3 by 8, and the value of W is 1000, which is 10 power 3 kilonewton. So 10 power 3 again, in order to convert into Newton. Length is 1 meter, so 1 square. D by 2 is 10 centimeters, so 5. 10 by 2 is 5. Okay, I mean depth is given as 20, sorry, so it's just 10 centimeter, and so 10 centimeter is 0.1 meter by area moment of inertia, which is 10 power 3 meters. So this is what we have, and if we cancel everything, 10 power 3, 10 power 3, we get 3 by 800, so it's basically 300 by 8, which comes out to be 37.5. okay, and remember that for the force units we have used Newton, length is meter, so Newton per meter, so 37.5 Newton per meter square is the stress value. Okay, so this is just a very simple problem. Thank you.